Hello everyone. On behalf of Team Current Affairs Review, I Anthony welcome you all to the discussion. As in our last discussion, when we were examining and analyzing the atmospheric phenomena, it is important to keep in mind that they are constantly in a state of flux. We have also discussed how meteorologists have identified the structure, characteristics and distribution of cyclones. By the way, if you have missed the last discussion, you can get the link which is given in the description box, or you can visit our channel as well. So today, taking into account the last 5 years, we have seen a considerable increase in frequency and intensity of tropical cyclones over the Indian Ocean, where both Bay of Bengal and Arabian Sea become susceptible to the changing nature and pattern of tropical cyclones. Although with growing advancement, we are able to detect and analyze the tropical cyclones to avoid the economic loss and fatalities. Hence today in our discussion, we will put emphasis on dynamism of tropical cyclones over the Indian Ocean. Before moving further, firstly we will discuss on the Indian Ocean's dynamic nature, secondly the recent increase in intensification and frequency in Indian Ocean, and lastly monitoring and tracking cyclones over Indian Ocean. So let us start with dynamic nature in Indian Ocean. In tropical and subtropical latitudes, the tropical cyclones are one of the most frequent hydrometeorological disasters, wreaking havoc on coastal and sea-based communities. With hundreds of fatalities and billions of dollars in property damage, these have been the most devastating natural disasters to hit the North Indian Ocean's coastline. India has been sensitive to these conditions because of its limited continental shelf, low coastal terrain, high population density, geographic position, and physiological characteristics. Recently, researchers looked into the asymmetry between the Arabian Sea and the Bay of Bengal, concentrating on years where the Arabian Sea or the Bay of Bengal had the majority of tropical cyclone activity in the North Indian Ocean. According to the meteorologists, the Bay of Bengal, where intense cyclones develop, is concave or shallow, and when strong winds push the water, it condenses into a storm. Hence, the trough-like shape makes storm production easier. The Bay of Bengal's location is further complicated by the high sea surface temperature, which heightens storm fury. Also, El-Nino and La-Nina episodes have a significant impact on cyclogenesis in the Bay of Bengal. The Bay of Bengal also receives more rainfall due to the slow-moving winds and warm air currents that surround it, which helps to maintain relatively stable temperatures throughout the year. The continuous warm water input from perennial rivers like Ganga and Brahmaputra makes it difficult for the heated water to mix with the cooler water below. Lastly, lack of air movement from northwestern India to the Bay of Bengal during the post-monsoon season is another element that could cause cyclones in the Bay of Bengal. The Arabian Sea, on the other hand, is calmer because of the stronger winds that help to dissipate the heat, and there isn't always fresh water present. As a result, heated water can mix with cool water below the surface to lower the surface temperature. Winds from the Pacific Ocean are weaker and rarely reach the Arabian Sea because of the Western Ghats and Himalayas. But recent developments suggest that Arabian Sea is having significantly more storms compared to Bay of Bengal. And to identify this, we will look now to the second part of our discussion, that is increasing frequency and intensification in Indian Ocean. The deadliest weather-related natural hazard in terms of loss of life and property and infrastructure continues to be the tropical cyclones. There has already been a discernible rise in the frequency and strength of cyclones with greater intensity due to the global warming. Forecasting cyclones is becoming more difficult due to rapid intensification, and more with these powerful cyclones with rapid intensification are anticipated. But what is rapid intensification? It is the maximum sustained wind speed increase of at least 55 km per hour during a 24-hour period. Previous research has demonstrated that tropical Indian Ocean is warming at a quicker rate than the rest of world's oceans owing to global warming. High sea surface temperatures are more likely to produce marine heat waves, which are extreme temperature conditions that last for days to months. Due to marine heat waves, the ocean is intensely warming, and which has serious socio-economic effects including the fish deaths and coral bleaching. It also has the capacity to interact with and affect other extreme occurrences like tropical cyclones. Extreme occurrences like marine heat waves and tropical cyclones can form and intensify of the anthropogenic warming of the oceans and atmosphere. Hence, this typical phenomena was identified during the cyclone Amphan in May 2020, which intensified from category 1 cyclonic storm to category 5 super cyclone in less than 24 hours. And it was the first super cyclone in the Bay of Bengal in the last 21 years. With this, not only the Bay of Bengal but also the Arabian Sea is becoming into the ideal ocean basin for the development of cyclones, where a spike of almost 52% was noted since 2001. Furthermore, it has been observed that cyclones in the Arabian Sea move more slowly, absorbing all available energy while at sea and ultimately intensifying when they reach the coast. For example, Cyclone Taukte originated near Lakshadweep in May 2021 and moved north before making landfall on Gujarat coast. The study also noted that over the Arabian Sea, tropical cyclones accumulated cyclone energy or overall wind energy over the course of storm and had roughly tripled, indicating the potential magnitude of recent warming. With this, it is true that such events will become more common owing to global warming in future, with Indian Ocean experiencing a rise in tropical cyclones with both strength and frequency. Now, with the growing increase in cyclonic condition, advancement over cyclonic detection and monitoring has shown improvement. With this, we have come to the last part of our discussion, that is monitoring and tracking cyclone over Indian Ocean. The tropical cyclone forecasting has proven to be the difficult task. In order to precisely estimate the position of the cyclone and deliver the necessary warnings for disaster management, numerous techniques and models have been created. Now we consider the recent advancement and methods of data assimilation, such as 3D variational approaches were used to assimilate the satellite derived data in order to enhance tropical storm predictions. At present, meteorological data from INSAT 3D and INSAT 3DR satellites are operationally received and processed using the multi-mission meteorological data receiving and processing system. Also, visualization tool called real-time analysis of product and information dissemination RAPID was created by Indian Meteorological Department and Indian Space Research Organization in order to track and analyze satellite images and products from INSAT 3D and INSAT 3DR. RAPID has also a no-cast tool that is reliant on satellites for its prediction. Additionally, satellites weather radar network currently covers the entire nation with 33 Doppler weather radars, including radars from ISRO. The current radars have been networked to deliver data to supercomputers in almost real time for incorporation into numerical weather prediction models for short range forecasting. So this is the end of our discussion of cyclone series. We will bring more interesting and relevant topics for discussion further in our upcoming videos. And if you like the discussion, kindly hit the like button and subscribe our channel, and also you can visit our platform currentaffairsreview.com and avail the PDF of today's discussion. So thank you for watching our video. Have a nice day.